So we were talking about deploying satellites and robots to study the oceans. So naturally, the next question would be, what are some of the challenges in deploying and maintaining ocean monitoring technologies?
Yeah, it's anything related to ocean is quite expensive, considering the ship cost and the cost of equipment and approach to the ocean. One has to sail, and it takes about some of the locations are far away. It takes about 4 to 5 days to reach the location itself. Now, the scientists sail out for about 30 days and come back. Till the time they have no other way to stop it, they will be always on the vessel to collect data. The challenges could be anything in the ocean is linked to the first and foremost thing is the weather conditions there locally. When you deploy this instrument, you need to have a good weather conditions. It takes time to deploy. The water depth could be 4 kilometer or 5 kilometer. The instrument deployment methodology is very strenuous and systematic. So that is the one part, and other part is about census and providing quality data. We need to do calibration and maintaining it well. And we need to important thing is that we need to have a very dedicated team and who will work. I always tell them like unsung heroes. They leave the family, go and deploy and maintain instruments and function. And anything malfunctioning, it's difficult for us to get the ship time to go there and work on it and know what is happening globally. People are in these countries are sharing the facility, like India and US. We share the facility like ship time, and we share the expertise. They are advanced. They come and work with us. Indian government and US government has got a joint data portal, first of its kind. We are sharing the data sets outside the exclusive economic zone for anybody to work on it. So this is what we make people to understand today, even the prediction to improve the science, the data sets play a major role. And today, globally, what even last year I was working in UNESCO, a program called Global Ocean Observing System, where my role was to bring 150 plus countries together. And I had a unique opportunity about out of 150 UNESCO member countries, we have 140 have got coast, we call coastal nations, and 10 are landlocked, like Switzerland and Nepal, Afghanistan, they are landlocked country. Now, I had, and we got mixture of countries. Some are least developed countries, some are island nations, like we call SIDS, small island developing states. And when you talk about all these aspects, India at par with US, Canada, Japan, UK in having the ocean observation. We call ocean observation data collection. But many other countries do not have. Now, what challenge is that the exclusive economic zone, the country has got sovereign rights. Like you've got land and sovereign rights, others cannot collect data. Ocean also has got sovereign rights up to 200 nautical miles. One nautical mile is 1.8 kilometers. That's the distance up to which India within the India's EEZ only India can collect. Any other country only they can collect. Now outside the EEZ anybody can collect, and they have to. There is a United Nations UNCLOS is an agreement. As a part of that, we need to work on it. Now challenges are we are talking about the ocean. Ocean coverage of data collection is not even 50%. And within the EEZ, some of the nations may not share the data. Only the open ocean data sets are shared. This is what United Nations is working on it, trying to see how, for disaster purpose at least, for tsunami early warning, cyclone, we need to share the data. Then only our prediction and models will be much better and improvise. Without that, it will be very difficult we, for us to have accurate prediction. So these are all the challenges we face, technological challenges, operational challenges, and one is a policy challenges. In spite of all these things, the countries do work together. India has got a prominent role in this region, and we provide the regional warning, not only for our country. We provide the regional warning. Our Indian Meteorology Department is having a larger role to play in these aspects. Now we have improved a lot. Coming back to 25 years ago, and the prediction of cyclone, you are from Calcutta, you would have seen the Amphan cyclone. which hit on 20th May 2020, where the whole India was locked in by COVID, and this cyclone crossed. We were monitoring it. And in NIOT, when I was heading that division, we were keeping the people continuously monitoring that. And one important point I want to stress, for any cyclone, we need minimum of six parameters to have the prediction. Three come from the ocean, three come from the atmosphere. So the ocean data sets are provided by us, advanced data sets IMD collects, and it also comes through satellite. And in addition to that, many more parameters are required. I'm glad to say that 20th May 2020, the landfall in Calcutta was well predicted. And thanks to all the missionaries, government agencies, and people, we all have cooperated. And the death roll is not only single digit, who ventured out in spite of warning. This was well appreciated by the World Meteorology Organization. They wrote a letter to the government of India for providing regional warning. It's not only for India, even the warning was for the neighboring countries. Bangladesh, Myanmar, Sri Lanka, Maldives, they all got a warning from us. So this is what I would call it as a science reaching the society or technology reaching the society.
Even the recent cyclone that we had, on 25th of October this year, like it was only a month ago, the cyclone Dana, it was also, well predicted to, it was predicted to make its landfall in the coast of Odisha, and it did make its landfall,
Yeah.
in the ballpark of where it was
Yeah,
predicted
it's
to
very,
hit.
you have to understand, it's very complex. I
Yes.
told you earlier, the ocean and atmospheric interaction, the the cyclone movement is linked to the sea surface temperature. I don't know how many of you are aware. We track it. We monitor the sea surface temperature. At times, the cyclone doesn't move. It changes the track and it remains in the ocean and it comes with a larger energy. Sometimes energy get dissipated. It's all related to the energy level. When the landfall takes place, the energy level is so much that it can uproot the trees or the installation, whatever we have got over there. So you have to understand the nature, how complex it is, and we need to be prepared, and we need to accept this warning and follow the rules and save ourselves and save the infrastructure and the facility to the support of the mankind.
So we have, the state of the art of our communication is through, electromagnetic waves. Like we use radio waves to communicate over large distances. But as I understand it, it is notoriously difficult to communicate using radio waves under the ocean. So, what technology does this ocean robots and submarines use to communicate with us from under the ocean?
Fine. This is the underwater communication only by acoustic. The
Oh.
electromagnetic radiation doesn't work there. So the acoustic communication is the only way where we can communicate and transfer the information in one to one. Maybe if you allow me, I can talk about tsunami early warning, where whatever you said, this complexity is faced. Can I explain about tsunami early warning?
Yes, sir. That is the next question. The next
Yeah, I will
question is,
merge. Yeah,
are there
yeah, I will
any?
merge here.
Yeah,
Yeah.
yeah, yeah. So, are there any specific regions or phenomena that remain difficult to monitor or understand? Like, tsunami is one such challenge. Like I think we do have some sort of systems to, warn people of coastal regions. So, can you just elaborate on that?
Yeah, you got two questions. One is which are all the region difficult to monitor in the
Yeah.
ocean? There are regions like polar region, Arctic and Antarctic, which is cold weather and ice, where the monitoring is really challenge. There is also a region called Southern Ocean. It is nothing but close to Antarctic. That waters are always they are very strong currents and strong winds for anyone to go and work there. And deep ocean. We still don't know what is happening in the deep ocean. Even the IPCC report talks about the deep ocean is not known. So the conventional methods or the models do not work there. I am part of an executive committee of a Deep Ocean Observing Network from San Diego, and we are working. Recently, we had an international workshop where various experts have joined together. 20 models were run, and none of them could predict deep ocean. Deep ocean is the pressure is very high, the temperature is very low, and there are organisms living there in deep ocean. So India has launched a deep ocean mission by the Ministry of Earth Sciences to understand all this aspect and develop technology to study further. So this is another the region when you talk about that deep ocean is one region, and deep ocean has got hydrothermal vents. Like you've got land volcano, deep ocean has got hydrothermal vents. Coming back to the other complexity you're talking is tsunami early warning. That is until 2004, December 26, we never knew the name called tsunami. We experienced one of the major disasters, still the largest ever the disaster mankind has faced is 2004 tsunami. Subsequently, Government of India took initiative to provide a warning system there. There are two fault zones. You must have heard about the plate tectonics. We live on Earth. The plates are about 40-kilometer thick crust. In the ocean, it is 8-kilometer thick crust. These plates are always on the move. Now also it may be moving and colliding. If you want to see that US Geological Survey website, I had it in my office. It will show you something less than 2 Richter scale, 3 Richter scale, which is not felt by us. The larger level is felt by us. Now, what to know about tsunami is that there are three waves. One is wind-driven wave. We see in the coast when you go there. Next is tidal wave between the gravitational pull of sun and moon. Third is tsunami wave. The first two waves are short waves. The wavelength is short. The tsunami waves are long. The tsunami wave happens when the fault zone, when they collide each other with a large amount of energy, and the water gets trapped there. The sea level retracts. Then again, when it joins back, the sea level rises. Now, the movement of water on the surface is equivalent to jet aircraft. It's about 700 to 800 kilometers per hour. The challenge is that if you are sailing on the sea and the tsunami wave is moving, you will not be feeling it because the sea wave height may be 1 meter height. The depth of water is 3 to 4 kilometers. You will not feel it. But when this wave approaches the shore, depends on the bathymetry or the seabed topography, its height can increase. It can become 10 meter, it can become 8 meter. In the case of 2004 tsunami, the Nagapattinam region close to the Sri Lanka, that region where the Sri Lankan landmass has diverted the water, we have studied, we have published work up to 3.4 to 4 kilometer level water has gone. Now, when this water gets into that, definitely the people will be affected or the infrastructure will be affected. Now, what we have done is that what the NOAA has done an important work is that can you measure this? One possibility of measuring is that I told you deep ocean is pressure is very high. The fault zone, keep monitoring the pressure. Say the pressure is at 4,000 meter water depth is 400 bar. 1 bar is 1 kg per meter square. That is what we breathe. Whatever we breathe in the atmosphere is 1 bar, 1 unit, you can say. It is 4,000 meters, 400 units more. Now, this pressure sensor can monitor any change in the water level leading to the pressure on the sensor up to 1 mm in 6,000 meter. Very complex. Now we deploy the sensor, it keeps monitoring it. When the tsunami wave is happening, it just gives you that yes, something is happening, some wave is happening. It pumps the data. Now I told you last question, underwater communication is acoustic. So what we do is that from the sensor, the data goes by acoustic to the surface. From the surface to satellite, it reaches to the shore. This is what tsunami early warning works.
Okay, so are there any ways to, predict in?
Yeah, what we do is that in INCOI's Tsunami Early Warning Center, they got a pre-predicted models. They provide early warning, and subsequently, to confirm that these data sets provide them. So globally, there are many in countries. India is proud to have our own tsunami buoy, we call it Sagar Bhumi. All others are importing from other US. So we're having these systems installed, five of them in Bay of Bengal, two of them in Arabian Sea, close to Makran region. So these two fault zones need to be monitored. We are comparatively much better. Many, in addition to that, on the shore, we measure the sea level rise by the tide gauge. And also when the tsunami happens, there could be changes in the landmass. We monitor accurately the GPS of the earth, like in Andaman region, we are monitoring it. So the whole tsunami early warning network of different sensors. If you are interested, please visit the website and read about that. We are at par, and we also conduct mocks trials for the people to understand how the evacuation is. So there is also a tsunami readiness program, which UNESCO IOC has launched it. India has done few villages in Orissa and West Bay of Bengal. They are equipped with the facility called readiness activity. So that is bringing the society into the fold and making them to have an awareness in the case of early warning.
So how much time can this tsunami early warning system buy, like for rescuing or for evacuation and all that? How much
Yeah,
time can we expect?
normally the warning has to come in 5 to 10 minutes. They provide that. Particularly, initially they have a scenario when the earthquake happens that we know very well prediction clearly where the earthquake is happening, but earthquake cannot be predicted. After the earthquake, we can monitor and say where the earthquake has happened. On the basis of the energy level, they can say that yes, there could be tsunami, or they'll confirm it with the tsunami buoy system deployed over there. So all this information is informed to the Ministry of Home, and they in turn provide to the coastal states and to the district collectors of the coast. So the whole network is well established in India and many other countries. They have a good coordination. They have a regular meeting to have the preparedness.
So suppose an underwater earthquake goes off and we kind of predict that a tsunami is going to happen. So can we relay this warning, sufficiently early enough so that evacuation efforts can be taken place?
That is what the whole system is working from the district administration to the village level. They have identified the representative NGOs who will in turn forewarn them. The challenge for us is from the fault zone, the tsunami we have to travel. We have got more than close to 1.5 hours, like from the past experience. The biggest challenge will be from the Nicobar and Andaman region, where we have about 20-25 minutes, very short duration to evacuate. Whereas comparatively in the mainland, we have time for us to evacuate and forewarn the people. And the system they have been doing the mock trial, they check any malfunction is there, any loophole is there, they try to address those issues.
Okay, so are there any possibilities that sometimes someday a false signal goes up and uh, there isn't a tsunami, but the system shows that there is going to be a tsunami soon? So any
Yeah, yeah. That is
false
this
reading like
happens
that?
in Pacific. Yeah, Pacific region. The false alarm we call it. False alarm is much more there. And in the case of India, in COIS, our Minister of Earth Sciences, I'm glad to say that we have been controlling it by various measures. At times, our predictions are much better, well appreciated. Even the past one or two incidents that has happened there. So we have a good monitoring mechanism and understanding about the system, and we have a good discussion with the various agencies, and also among the countries we discuss. For example, we have a connection to the Australia and Thailand and many other region, so that helps us to provide a correct warning to the people by having a closer interaction. So
So in that case, if a false alarm happens, how do you tell the difference between, a real alarm and a false alarm.
Yeah, this is what in Pacific region earlier they also address these loopholes now, and they've got a better way to do that. Now, when you keep false alarm 2 3 times, then the people won't be serious enough to do that, to accept when the real warning comes. So globally, this is what UNESCO Intergovernmental Oceanographic Commission, they are addressing these, reducing this false alarm, making it more affirmative. That is happening now. That is changes have taken place. A lot more efforts are happening, and the country to country interaction. So that is helping us in this regard. Our understanding of science also is improved a lot over the days to come. So there are also new possibility we call smart cable. You know very well, telecommunication cable today, what we are talking is mainly because the telecommunication cable, optical cable is laid on the seabed. There are about 10 lakh kilometer length of cable globally. And these cables provide today what you're talking, even today's meeting is happening mainly because of that. Now, I was also part of a joint task force by three UN bodies, UNESCO, WMO, and ITU, International Telecommunication Union, where we have requested these telecommunication companies, like Google has got 16 cables worth of $16 billion. Many other private agencies and countries have got telecommunication cable. Can we attach sensor to that? So there is one possibility. The first project which Portugal has agreed, the government of Portugal has agreed in laying the cable. When these sensors are attached, we will be getting more amount of data sets continuously, because optical fiber help us to get seconds level of data. Currently, data sets are limited due to the satellite communication. That is being addressed in a larger perspective by a larger team. You will be surprised to know that the telecommunication cables are very expensive to lay on the seabed, and they allow us to install sensor. They are also uh, technically very strong, that their main activity is not disturbed by having the sensors together. So this is one new frontier area we are addressing, having these sensors attached to the telecommunication cable. Another possibility, about 3 years ago, I was also chair of International Telecom Tsunami System. There's a committee. I was global chairman. We were told that the Mr. Sundar Pichai, CEO of Google, they were able to predict cyclone and earthquake, underwater earthquake, mainly by this telecommunication cable. I'll tell you briefly. Underwater, when this telecommunication cable is laid, optical cable is laid, what happens is that when the cable is coming to the shore, they convert the optical into electrical. The same way around it happens other way around. Now, it's very calm, quiet underwater when the cable is laid, but they keep monitoring any other extra noise is coming or any disturbance is there. So very accurate and minute level they monitor. There is a scientist who has developed an algorithm from San Diego. He has provided to Google, and that helps us to give any small disturbances. Like I told you, acoustic is going as the only communication. When the raindrop falls or anything, and the cyclone disturbance is happening on the surface, that disturbance is transferred to that through the cable they are able to monitor. So we are trying to approach them, what algorithm, what they have got, that will help us to have more understanding, to have a better warning. So this is a different area, different thinking we are working towards, providing early warning to the people living along the coast.
So that means the noise of these optical fibers is practically data for meteorologists.
Yes, you rightly
Mm.
pointed out. Disturbance or noise, signal to noise ratio, the noise could be useful for other study. So then again, the scientists need to be prepared to have a better computing facility. When the large data sets come, will be able to run the model, and whether the computation facility is good enough. I was also part of another committee in the World Meteorology Organization. Today we have a 1.5 exascale computing facility, supercomputers. In future 2030, whether data sets are provided by various means like sensors, equipment, ships, aircraft, satellites, will that be requiring fast computer or for more storage? So we were addressing with the major the computing companies like HP, and many other things, and we are IBM, and we are discussing. We brought out a report also in that regard. I'm glad I was part of such international committees. I also learnt a lot how the meticulously they are planning in a futuristic way.
Okay. So what steps are being taken to educate the citizens of India who are living near the coast, to educate them about, this ocean phenomena, like their life depends on these things, right? So what steps have been taken to educate them about these things?
Very good question. There are also efforts taken by the central government and state government and agencies. There are meetings to take place, and the vernacular languages, they also conduct workshops. And in COIS, they bring the fishermen to their office to show them, like early warning, what type of activity they are doing. And in turn, train the trainers. They provide training to the state government agencies, who in turn provide them to the local people living over there. In addition to that, I was also part of a group, a DST program, where in Tamil, more than about 30, 35 lectures we organized and webinars. And all the eminent people we spoke and connected to the school and college children, they joined us almost on a weekly basis. We have done that's a DST program. So many other activities are happening now. YouTube also has got various in different languages, and even in the United Nations level, they have a program called Ocean Literacy. And also, other way around, these people living along the coast, they have got their own the traditional knowledge. How do you acquire that? Particularly in the island nations, these knowledge, vice versa. We have to learn from them. That is also, I was part of another committee, Ocean Best Practices. We are trying to learn from them and bring it in the larger level. I was also part of in WMO in a capacity building exercise. The discussion came on languages. So now you know very well the technology is improving, converting from English to many other languages possible. So the education is bringing an awareness in being addressed on the highest level. That is, as you rightly pointed out, is very important. And also school curriculum level, we need to address and provide the material for them to teach. The teachers also need to be educated. Smaller level, I provide a lot of lectures to the school and college children. That is one of my main motto, to bring an awareness on all these aspects. And that is my small nano level contribution to the whole exercise. I was part of another global exercise, more than about 30 capacity building exercise we have done, in particular, even in island nations, we have done it in the global level.
So, since we are talking about, citizen awareness programs, so the last question of the day would be, what role can citizen science play in ocean observation?
Yeah, this is what we have been discussing about that. The days to come, the more and more data sets will improve our predictability. So I was also part of another new working group called Fishing Vessel Observing Network. You know very well, see, Bay of Bengal alone, more than 2 lakh fishing boats are there. Now I'm part of a group, and recently the meeting was held in Australia. I couldn't go there, where there is a simple sensor which will be given to the fishermen. They can attach it. That will provide temperature and also provide, when the fishing is taking place, within the net, what how much amount of fishes are caught with a camera, so that they get the benefit out of that. So this new project is again UNESCO IOC Goose endorsed program. So I'm trying to help them in this region to collect data. Tuna fishing requires temperature data in the deep ocean. So this is a part of the citizen science. Another work is on the sailboat. Not much in the Germany and Europe. A lot of sailboat competitions do take place. They have agreed to attach sensor and provide data sets. And some divers, they are also collecting data and they'll be sharing with us. And post cyclone, also we need to know whether the prediction is correct and where and all landfall. The citizen can take picture and upload. This is one of the UK government has done an activity where the citizen can take a respective latitude, longitude picture, can upload that. Then we'll clearly know that how the prediction vice versa has improved or predicted perfectly, that can be monitored there. So the devices what the citizen are using, they will be equipped with a miniaturized sensor in the future, and different way these data sets could be collected. I'm sure that the more and more data collection platform would come. I have also suggested like the colleges and university, they can be linked to their ranking to make them to collect data and shared with the government agencies, particularly Indian Meteorology Department, for the better prediction, not only on the coast, hinterland. That's one area I suggested. So the days to come, simplified sensor and bringing awareness, because the solar powered sensor, if you have, they're not much of an expenditure for them, and satellite communication is improving, our insat communication is improving, so that the data transfer could be possible. So I'm sure that the citizen science and also this is my one of my book. I published a book on the observing the oceans in real time in Springer. I'm glad to say that more than 30,000 downloads have come and 200 books have been sold. Many universities have got one chapter. We have allotted that. Today we have a prediction by which we want to talk about cyclone. There could be in future. I want to see the biodiversity of so and so location. Can I have an app for that? I'm going for an vacation. So you mentioned about coral reef. What type of information I can have? So the kids are really well equipped now, and so these data sets can be collected and given to them. Another important point is we are talking about physical data, biological data, chemical data. How do you merge? How do you we call it as a digital twin? One data sets can be used for another applications. So this is one area. Another one, I am also part of one more group is on a frontier journal for kids, where experts write articles, kids they correct it, kids they review it in their own language. So this is one new work I have taken up. I'll be publishing, and I'm also writing a book on ocean by the Minister of Information Broadcasting in Tamil. That is the what are the mysteries of the ocean. I've given a topic like that. So these type of awareness and bringing citizens into that, whatever they observe, that should not be ignored, that we make them to bring it to the agencies, and smaller information, everybody carries a camera. One major last point I want to say, practical experience in Australia, and everybody goes and take a picture of a coast in a top of a small hillock there. They have attached a picture taking point and connected. Everybody can connect to the Facebook. Now the coast, how the seawater is coming in, erosion is taking place. 2 years data sets they have collected by citizen. Now, there's amazing information which even satellite cannot predict to that level. That data sets are shared to the students. If you are doing a project work, it's available. So these type of activities are possible. I was also responsible to conduct underwater robotic competition for the college students. Minister of Earth Sciences, we have sent a winning team to San Diego, first of its kind. And 10 years we run the program. Today, country has got 25 universities and college, three startups. One of them from Orissa. They came, the Shark Tank, you must have heard about this. They bidded for that and they got a funding. So there is a potential there. There are more startups coming up, and the more robotics can be developed by these. So citizens and students and we are all bringing awareness. School kids, amazing. I had organized a webinar where MTS, Marine Technology Society, two school kids gave a video talk, wonderful talk. So at times their knowledge from the internet, what they collect and they ask questions, really amazing for us. And these type of information to be brought into them, correct information to be brought them. That's what, when you talk about climate change, we should make them to run the tool. Should make the software in such a way that you run the tool, you understand what is happening, and don't wait for anybody to publish. So you bring an awareness what changes we need to do as an individual. We talk about climate change, it has to start from an individual, start from home, like Dr. APJ Abdul Kalam said. You start from the home, start from the street, then go to the village, then district, then the national. That's what we need to look at it in climate change also. I'm sure that this podcast we have shared this information The citizen science is important aspect. There need to be looked at. Citizen technology, jugaad we call it. That technology also need to look at it in a broader level. So we have a simplified technology available for even common man to use and help ourselves for the better future. That's what real sustainable development will face it.
And with that, we have come to an end of today's wonderful session. Sir, it's been a pleasure talking to you, and thank you for joining today's session. And viewers, please follow us on Instagram for updates about future episodes. And do support this channel by liking this video and subscribing to this channel and sharing this video. And go check out our other episodes. And hey, did you know that we are launching a new magazine? Yes, you heard it right. It's called The Scientifical, a treasure trove of science information and cool puzzles just for you science enthusiasts. So, yeah, follow us on Instagram and we'll keep you posted about this new magazine that we're coming up with. So, with that, thanks.
Thank you very much. I just want to thank all my former colleagues and National Social Technology, Ministry of Earth Sciences, and UNESCO, WMO, UNEP, all the UN agencies with whom I have interacted, and my family. That made us to learn, and I'm still learning. I'm also teaching in Anna University, climate change and the ocean. There are much more to learn each other ourselves and to support the society and work for ourselves. Thank you very much. Thanks to you all, your team, for making me to come and join with you. It was a wonderful experience for me to interacting with all of you. And anybody would like to have any questions, you may get my email ID. Please ask questions to me. Whatever little knowledge I've got, I'll share that information to you all. I'm glad to do that. Thank you very much.
Okay. So, we'll share the email ID on the description of this video. So, yeah, with that, we come to an end of this session. Thank you very much. Thanks for joining. Bye bye.
Bye bye.